Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and I am excited to be here with you on this journey of mastering mathematics in grade 12. Well, I'm going to start this video by just telling you that I might go into a lot more detail in this video than you might think, because this is a very simple question, a relatively straightforward question, but I also want to share with you more about hyperbolas. But before we get into that, go and try the sum yourself. So this is question 5 of the November 2021 paper written by the Department of Basic Education. Hit the pause button, try it yourself, and then you look at the rest of the video. So when we look at this specific question, I want to start off by actually interpreting the question. So my first basic interpretation is looking at that A value. So the A value is smaller than 0. And let me just pause for a moment and tell you something that's very crucial from me to you. Before you answer any question in mathematics, go and analyze. Analyze, get as much information out of the question as you can. So I'm going to start by saying if A is smaller than 0, we know that the function, the hyperbola, will lie in the second and fourth quadrant. Then we can definitely get the one asymptote by looking at x minus 3. Now, x minus 3 may not be 0. That is an interesting little thing that you need to remember. Why may x minus 3 not be 0? Because then the graph is undefined. Big word, big important word, undefined. Then we can also get our horizontal asymptote, y equal to positive 2. Now, I'm going to go one step further than just your superficial analysis. And let's look at the axis of symmetry. Now, the axis of symmetry, although not asked in this question, put a pin in it. Both DBE and IEB matrix, they love to ask it. So what are the basics about axes of symmetry? The basics of axis of symmetry is that it's either going to be one with a positive gradient or one that has a negative gradient, and it passes through P, Q. Now, what is P, Q again? Remember, that is your asymptotes. That's why I colored it in the same color as your asymptotes. Red for the vertical and orange for the horizontal. So in this case, P, Q is 3, 2. So P is 3 and Q is 2. But I don't really like this so much. I'm being honest with you. The less things that I have to memorize, the better. So what I love to do is look at my second option. Or I can simply say, okay, I've got one with a positive x plus c, and I've got y equal to negative x plus c. And this passes through the coordinates where the asymptotes cross. You get this. So I can rather just say positive x plus c and negative x plus c. Those are my two asymptotes. Of course, y equal to that. And it passes through that coordinates, those coordinates where the asymptotes cross, so 3, 2. But more about that coming later on. Let's go and actually answer the questions. 5.1. Write down the equations. So not values, not coordinates, equations. So don't just go and say 3 and 2. No. Say x equal to 3, and y equal to 2. If you don't put that there, you will lose the marks, guaranteed. Next up, write down the domain of f, so the x values for which the graph is defined. Now, here it's important to know that we're talking about a hyperbola. So, it's defined everywhere except at the asymptotes. So, in other words, x can be any number but not 3. So that's how we write it. Some teachers might say to you, you must write it like this. X can go from negative infinity up to positive infinity, and x may not be 3, and that's exactly the same thing. It's exactly the same thing, okay? Or, and I just love to give you different options. You could say from negative infinity to 3, and from 3 again to positive infinity, doesn't touch, and I just like to put a big or in the middle. So any of these 3 options are 100% correct. You can choose your own. Let's look at the next question. The next question, 5.3. Determine the coordinates. So I need an x and a y value of the x-intercept. So in other words, y is automatically 0. So this is the way I love to plan out questions. Do the information, jot it down, and you already have certain things. Then I go and look at my formula, which was given to me, and I make y 0. So I replace fx with 0. Now, ladies and gentlemen, solve for x. So I'm going to transpose that fraction and multiply straight through by my LCD, which says that I'm going to sit with that specific formula or equation. Now I'm going step by step, isolating x, so getting all the x's to one side because I've got a linear equation, and now I'm just dividing by 2, so therefore x is 3,5. Have I answered the question? No. The question was determine coordinates. I've got to give the examiner coordinates, otherwise they may deduct 1 mark. So I've got to finish my sum off by saying 3,5 semicolon 0. I hope you've got that. Okay? Next question. Write down the coordinates. Again, x and y of the y-intercept, and that's why I make x 0. So I'm going to replace my x in my formula with 0. Substitute it and calculate it, and my answer is 2 1/3. The last question is now, have I answered question 5.4? No, I haven't. I've got to write it as a set of coordinates because that's what they're asking for. Please answer the questions, ladies and gentlemen. Let's have a look at the next bit. Question 5.5. Draw the graph of f. Clearly show all asymptotes and intercepts with the axes. So I'm going to do it step by step. First of all, show the asymptotes. Look what I'm doing there. I'm not just putting lines. I'm writing on top of the line x equal to 3. And next to the horizontal asymptote, I write y equal to 2. I want you to take note of it because this is what examiners give marks for. If you don't put those values there, they can subtract the mark. Next up, my y-intercept and my x-intercept. And then I have to draw the graph. Now, before I carry on, I just want us to think back. What was A's value? Well, A was smaller than naught. So we knew it had to be in quadrant 2 and quadrant 4. And yes, this makes sense. I've got it. It makes sense. Now I'm going to go one step further, ladies and gentlemen. One step further. And I'm going to answer a question that they actually haven't asked, which is the equations of the axes of symmetry. So when I look at the axes of symmetry, I'm going to start with the one with a positive gradient that passes through 3, 2. So if I look at that and I substitute 3, 2 in, I solve for C, and I've got y equal to x minus 1. And now, if I had to illustrate this, let me do it in my purple pen. If I had to illustrate this, it would basically look like that. A positively sloping axis of symmetry, meaning the left-hand side or above the line and below that line is a reflection of one another. So if I fold it across that line, the two parts look exactly the same. But how would the axis of symmetry with a negative gradient look? Or what would the equation be? I'm going to follow the same step. So substituting 3, 2 in. And now it's y equal to negative x plus 5. So this I'm going to draw with a red. Now let's not do red because I've already done red. So let me go blue. So that would be something like that. There we go. Ladies and gentlemen, although it's not asked, the examiners love to ask it. They love to actually tell you, give me the equation of the grade of the axis of symmetry with a positive m, or with a negative gradient. So you've got to kind of be careful which one they ask you for. I know this, I made this so much more complicated than they asked it in the exam, but I'm preparing you for your exam. They are not necessarily going to ask it for you like this. So ladies and gentlemen, this is Sarah van Grennen, aka Mr. VG, and I'm signing out for tonight. Have a beautiful, wonderful, and amazing rest of your evening. Please keep warm. I'm sitting here by the fire, keeping my toes nice and toasty. I love playing on those words. But you keep yourself safe. Even though the masks are now gone, please keep yourself safe. Have a beautiful and gorgeous evening. Cheers.